where we're busy working through one of the past papers, specifically the 2020 exam paper. And this is all to help prepare you for the semester test 2, as well as the exam. So you'll see that all the exercises and stuff that I do is on the VPL system, and which is what you are going to effectively use during the computer science semester test 2 and exam to effectively submit your work, or to have your work available for us so that we can mark it. Okay, now we have already covered a number of things in the lectures. We started off in the first evening just looking at the problem. We made some notes on our problem, and we did a design. And then last night, we created all the files that we normally would require for such a project. So the library files have been created, and we also started populating the library files. And we said that today we're going to focus on the command line arguments and maybe continue on with there. So the objective of today is really just to focus on command line arguments, really just talk about that again, see how we actually would do this in a computer science or a C++ program. And let's continue. So I'm going to share my screen so that we can obviously see what's going on. And again, what I'm going to do is I will do some work, then I will pause, and then I will look at some of the questions in the comment field, and then I will handle those questions, and then I will continue again. I will not be interrupted unnecessarily. So let me just make sure that these notification volumes and stuff is off. Otherwise I get, yeah, there we go, it is off. Okay, that's good. Let us basically just show you again the problem. Unfortunately, I had to reboot my machine. I didn't save all the notes that we made previously, but we're basically busy with this specific question paper. It's the, if you look there on top, 2020 exam paper, and it has to do with this social SRI epidemic modeling, where we're going to have a number of people moving around randomly in the world. Some of them are susceptible for being infected. We've got recovered people, we have infected people. And what was interesting is we actually made a note of that if a person recovers, then they can become immune. So there's actually a fourth type of character, which is kind of like it's a type of recovered person. And we did actually make a note of that in our notes as well as in the header file. And today we're going to continue with this initialization section. But before we do that, let's just quickly have a look again what we have already done. We have our main file. So this is the main file that you can see here, where we've included the header file, where all our function prototypes will be in, as well as the libraries that we're going to use. We have using namespace SRI space, so that if we ever use functions in here, it basically assumes it's part of the SRI namespace. Then we've looked at our header file itself, and we initially yesterday created the guard conditions there on top and the bottom, and we also included the libraries that we typically need. We have our using namespace, and then we created a number of typical things that we normally would require for this type of problem, but more specific for this one as well. We created two type definitions, one that will help declare and define our two-dimensional dynamic arrays. We have already created our integer values for the various features, so empty space, susceptible, recovered, infected, and immune. And we have created an output section where we're going to decide what characters we're going to output on the console. And we've created a section where we've got some return values or exit values like success, error, conversion, etc. In our implementation file, there's not much here at the moment, just a link to the header file and the namespace declaration. Remember, always create your function inside the namespace here, as well as inside your header file. Okay, so let's have a look at our next section, which is this line here. So I'm just going to highlight it. There we go. So we're looking at that specific line. It says the size of the environment. Let's see if we can zoom in a little bit more. And I'm going to make a few notes here. So on the side, I'm just going to say, so the size of the environment is the rows. and we want the columns, what they call the infection chance. So I'm just going to say chance, let's say infection chance. What is the chance that someone will get infected? Then there's a recovery chance, a chance recovery. There's an immunity chance, immunity, and the initial numbers of each type of characters. Now, initially, there's only these 3 types of characters. The recovered people aren't immune yet. So initially, there's only susceptible, recovered, and infected. So let's make a note of this. So let's say it is the total susceptible, the total recovered, and the total, is it infected? All right, now let's quickly count them. So it's 1, 2, 3, 4, 5, 6, 7, 8. 8 extra command line arguments that we normally need. Now, some of you might have missed the tutorials and the lectures when we did command line arguments. In Quick, this is what it is. So I'm just going to quickly open up a command prompt. Whenever we run a program, such as dir, okay, dir is a program, believe it or not, it actually gives us some output. You can give the program a number of command line arguments. Now, arguments means extra things that you can add on to the program. Now, in this case, for instance, if the argument is /p, that /p argument says that it will pause at every screen. But basically what happens is when the program runs, it actually reads these command line arguments and says, hey, this user actually ran it with /p, so I must do something specifically with it. So all these things behind the program name is what we call our command line argument. So basically that's how it pauses. So that is a command line argument. And when we look at a command line argument such as dir /p, can you see there are obviously that argument there /p, but dir itself is also, believe it or not, a command line argument. In fact, in the world of C++, both the application name, which in this case is dir, as well as all the various arguments behind that, separated by spaces, are counted towards command line arguments. So the number of command line arguments, if we just look at dir /p, is 2 command line arguments, where the first one is dir and /p is the second one. Okay, now obviously if we look at this from an arrays perspective, dir is in array number 0 and /p is in array number, index 1. So dir is at index 0 and /p is at index 1. And so you can go on. I can do b as well for basic. And now there are 3. So it's 1, 2, 3 command line arguments. And that's what you should consider when we work with command line arguments in C++. All right, so let's minimize this. Again, let's just count 1, 2, 3, 4, 5, 6, 7, 8. But there's a 9th one, which is our program name. Program name. There we go. The one that's on top. Okay, so we have to remember that when we include our counts. Okay, let's get to our programming now. Or let's rather pause and let's see if there's any questions before we continue. Oh, wow, no questions today. That is interesting. Let me make sure. Are the settings set so you can actually ask questions? Oh, yes, it is set. Okay, yeah, you can ask questions. Thank you. Because it was so quiet today. Normally I get overwhelmed with all the questions. This is last year's exam paper, Mr. Moraperi. Or Mrs. Moraperi, if you look there on top, CSC 01-2020 FSR.pdf. Okay, let's move on. Okay, so now the first thing that we have to do is when we use command line arguments in a C++ program, we have to do something special. Now this something special was initially built into the C language, and C++ went ahead and it took it over and implemented the same principle and the same mechanism. And the way that we do that is, remember, this is just another function, and this function has a return type, which is an integer, and it also returns some kind of number at the end of the day. It has a function name, and then by default, it has an empty parameter set. Now, if you want to use command line arguments with C++, you must do what they call overload your main function with the following parameters. And the first parameter type is an integer parameter. And we typically call this integer argc. So that is, and that stands for argument count. That means it will return an integer value, which is a number. That is the number of command line arguments that we have, or that was given to the program. The next parameter is this thing, which looks quite weird, character star star. But hopefully at this point in time, because you have looked at last week's lectures and tutorials, you will know that, hold on, star star, this is a pointer to a bunch of characters. And if we reinterpret that in a different language, it basically means it is a one-dimensional array of strings, because a string is a one-dimensional array of character. That means that is a two-dimensional array of characters, which effectively is a one-dimensional array of strings. And guess what? So in here, given our various indexes, that is the actual command line arguments that we're going to get. So that is the first step that we have to do. Now, before we continue, let's just save. Because we're using VPL, we don't have an interactive terminal that we can actually provide these command line arguments in. So Prof. Coulter has been so nice, and he has allowed us, and he has implemented a mechanism that will allow us to provide command line arguments to our program. Now listen up, this is important. If you want to use command line arguments in VPL, you have to create a file, so there's a new file, and you have to call it cmd.txt. Very, very important, command.txt. Okay, now once it's created, in here, you just specify your program arguments. So, and we'll put some arguments in there just now. Let's just quickly go back and let's see. So we need the rows, we need the columns. Okay, let's just put a few in there. Let's say our program will require, let's say 10 rows and 11 columns. And then what is next? The chance for infection. So there's 3 chances: infection, recovery, and immunity. So let's say, because it's let's say a high infection chance, there is a 30% chance for a recovery is it recovery? Yeah. Recovery, and then let's say there's a 20% chance for immunity. The next one is the total susceptible people that we're going to have, or characters, then the total recovered characters, and the total infectious radius. So let's see, susceptible. Let's make them all equal, 10, 10, 10. Okay, and that's all you have to do. So it's effectively a file name called cmd.txt, and then whenever you run and you run your application, it will actually use these as the command line arguments. Please do not include the program name here, okay, because we don't really know what the program name in VPL is. Just cmd.txt. You'll see that Prof. Coulter on the right-hand side actually did create a little bit of a note there as well. Please place command line arguments in a file called cmd.txt with each argument separated by a blank space. Okay, so please remember this. This is how you have to do it for the VPL. Let's just pause and see if there's any questions. That was my little notice. Okay, what do the rows and the columns represent? The rows and the columns of the two-dimensional world. This should not be so foreign at this point in time. If you looked at last week's tutorials, then this should be, so it's basically a grid. Okay, I'm not sure if I understand how we force someone to use the command line arguments. Oh, I see. Okay, good. How it is that we can declare constant variables outside the namespace within the header file, and yet it is recognized by the main file. Okay, you guys, you don't have to create functions inside a namespace. You can create functions outside a namespace. Then there are what they call global, well, I don't say global functions, but unnamed namespace functions. All right, or anonymous namespace functions. I think that's what it's called. So it's up to you. You can decide whether you want it included in a namespace or not. It will not stop you from using it. Very simple, either inside or outside. It has no effect. The only thing is, if you have it inside the namespace, then you can refer it with its namespace identifier. So let's say, for instance, we want to refer to chempty, then we can refer it to something like this: sri space chempty. Okay, that is if you have your constant inside a namespace, because then it has a surname. If it's not inside the namespace, then it doesn't have a surname. We have covered this already. Please look at this week's lectures. I'm not going to repeat this. Can you swap int arg? No, you cannot swap them around. It has to be in that order. So that's very important. Okay. Thank you for that question. I think because we include the library and those are consts. Okay. What's the use of a txt file? Why do we have to write it on the txt at the end? I have already mentioned that. That is so that we can get command line arguments. How do we know that this is the right number to use in the command line arguments? Well, you read the problem. All right, the problem specifically states that is the number. It says it has the size of the environment, the infection chance, the recovery chance, the immunity chance, and the initial numbers of each type of character must be separated by a command line. So we actually have that. It is specified for us. There is no other option. We have to follow the actual instructions in the semester test or the exam. That's why we have to have that number. If you don't have that number, then you did not follow the instruction and you cannot get your marks. Simple as that. Read the instructions. Right, next, because you include the header file itself. So since in the TXT we have numbers, then how would you make the user input the argument in runtime on code blocks? Mr. Sibanda, you can, this was demonstrated in the tutorial, so have a look at that. Are we going to learn enums and structs before semester test 2? No, we are not. It's not included in the scope for the semester. Will we convert the command line argument just like we do normally? Yes, absolutely. So I'm going to continue now and show you exactly how we will use the command line argument from this point onwards. We've just overloaded the main function at the moment. We haven't done anything further than that. Okay. Now we have to start using the command line argument. So one of the first things that we have to realize is because it is declared that we have to use this in the command line arguments, we have to make sure that when the program runs, the correct number of command line arguments have been supplied. If the correct number of command line arguments have not been supplied, then we cannot run the program further. Now, how do we do this? Well, very simplistic. We can do a little bit of an if state. We could say, hey, if argc, because remember argc returns the number of command line arguments. If it is not equal to the total that we want, so let's again count it, 1, 2, 3, 4, 5, 6, 7, 8, 9. If it's not 9, then, oh, not 0, then we are going to give an error. So I'm going to output an error here saying incorrect number of command line arguments. Please run. And then I'll just put a little end line here. And see error. Please run. And then I'm going to give it the program name. Because remember, the program name is at index 0. And then the next index is, oh my goodness, there are so many rows and columns, rows, columns. Oh, wow. Chance infected. Chance underscore, what is it? Recovered. Okay, and I will continue on the next line just now. Then chance infected, recovered, immune. And then total number of infected, total recovered, and then total immune. Wow, that's a lot of stuff. And if not, because none of this is true, we've already declared, we've already seen that, hey, it isn't 9, then please exit at this point in time. And the error was error. Let's quickly get it. I just want to quickly test something. Unfortunately, it's not intelligent enough to go grab the error messages from another file. But there we go, exit error argument count. Okay, so let's save this. Now let's just run it. If we don't see anything appearing, then we know our command line arguments, at least the number of command line arguments are correct. So I'm going to run it. Okay, nothing has happened, so it's all good. Now let's just quickly, just to make sure that I've modified my command argument file now. Let's run it again. I should now get that error message appearing. There we go. Incorrect number of command line arguments, please run. Oh, now you also know what the program name is. There should be a little bit of a space there. Rows, columns, chance infected, chance recovered, chance immune. Total infected, total recovered, total immune. All right, good. That worked. Thank you very much. Yay. Right, so let's just put it back 10 and save. Right, let's pause. Let's see if there's any questions. Okay, if the number of arguments is different from 9, can I ask the user to enter those values using cout? Absolutely not. It has to be. Why? Because of this thing. The size of the environment must be specified by the command line argument. Guys, do not try and JIPO the system. Must be specified via the command line argument. Okay, next. But there are 8. No, there are not 8. I've already covered this. Please watch the recording. There's 9. 8 plus 9. For the sake of the sake, is there an advantage or edge to using command line arguments over user inputs? Yes, there's very, very good advantages of using command line arguments. The whole Linux operating system is built on command line arguments, which allows you to pipe information into certain programs and using output from other programs to go into other programs. So it helps a lot in us writing specifically command applications or command prompt or let's say console applications to actually use command line arguments. There's many advantages of that. Probably has a niche purpose. Definitely not a niche purpose. It's all over the show. We use it every day. If you're an administrator, this is your bread and butter. If you cannot run certain commands without command line arguments, then it's very difficult to automate your job. Good day, sir. Why? When I put lots of if statements, the program stops running properly. I'm not sure. I cannot make a comment on that now because I cannot see your if statements. Please post this question on Discord or with an assistant so that you can be helped. I cannot just figure out from what you said. They're not supposed to just stop running properly. Okay, what I can say is if you do have many nested if statements, then consider whether it's really necessary to have that. It gets very, very difficult to keep track of very deep nested if statements. Okay, right now, this was the first thing that I wanted you guys to understand. So first is test the number of command line arguments. Next. Now we're going to have to take each of these command line arguments and put them in some kind of variable. So I'm going to first create these variables. So int rows, so that I can keep track of them so that I don't forget about it. Int chance infected, int chance recovered, int chance immune, int total infected, int total recovered, and int total immune. Okay, I think these are, let's count them again. 1, 2, 3, 4, 5, 6, 7, 8. Okay, they are all 8 now. Now I have to take these ones and I have to convert, well, argv1 and argv2, and I have to convert them into integers. For instance, if I do this, argv1, which I expect must be the total number of rows, then this will not work. So if I try and compile this, it will complain saying that, listen, you're trying to convert an array of characters into an integer, which is horrible. You can't do that. Okay, go for it. Give me my error. Thank you very much. So can you see that? It actually has a little red thing here on the side. Invalid conversion from character pointer to an integer. So you can't do this. So we have to try and convert these characters, because everything from the command line argument by default seen as a character, we have to convert that into an integer. Now, one C++ function that can do this is a function called any to integer. So this function can do that job. Now, I'll discuss this function just now. Just want to show you that it can actually work. Let's run it again. And I shouldn't see an error right now. Boom, connection closed. Thank you very much. No error. Now, what does this function do, and why do we want to make you aware of an alternative method? So A2I is built into the C++ language. As I said, it's actually quite nice in that it can try, it actually stands for any to integer. So it will try and take any type of data type, which is typically strings or characters or whatnot, and try to convert that into an integer. The problem, however, is if it fails to do that, then if you look at the instructions, then there's an unknown result. Now, an unknown result means it is actually dependent on the compiler and the architecture that it runs on, the result that you actually get here. So because it can potentially provide an unknown result when it fails, there are more robust methods to do this. I'm going to demonstrate one of these robust methods. And this robust method, I'm going to implement using a function, and this function will return an integer, and I'm going to call it getInt, and I'm going to give it a parameter of a string data type. So there we go. It will return an integer, and it takes in a string data type as a parameter, and the function name is getInt. Let's implement this into our implementation file, and what we do is we first declare whatever we're going to return. And then we use a very special class called a stream class. And we declare a variable called SS, and we initialize inside this variable the actual string characters into SS. Now, there's different ways in which this can be done. I like this syntax because it's quick and fast, plus it's already a C++ 11 language feature that we make use of. So basically, it takes this parameter, strint, so whatever we give to the function, as a bunch of characters, and it puts it inside SS. Now, SS is a cousin of the cin and cout functions themselves. That, remember, cin reads characters from that standard input stream. This is a string stream, so it's based upon the same principles of the cin and cout. Now, why is that important? Because of the following. We can do the following. We can use the stream operator. The stream operator is these little angle bracket thingies, and we can say take whatever is now in SS. Remember, we've put strint into SS, and stream it into int num. Int num. There we go. Right, now this may look a bit strange, but you should remember that we could have done this. This is one of the most earlier types of commands that we introduced to you in this course. What did this command do? It took whatever was on the input, standard input stream, and then it tried to convert it into an integer and store it in this variable. And that is exactly what we're trying to do here. But instead of trying to get it now from the standard input stream, we're just getting it from its own stream component that we've already plugged in there. Now, we can. What is nice about this method is it allows us to see whether this operation was a success or not. Point is, we can say if ss.fail, just like we did with the cin flag, if ss failed, then we know that that conversion was not successful. Now, in this case, we're going to use the function, and we're not going to be able to keep on retrying. Why not? Because there's no input from the user again. Basically, the user should have provided it from the command line argument, so we're going to immediately exit our application at this point in time, but at least let's just give some error. Could not convert strint to integer. Okay. And then exit. Still can't remember. So let's get the error again. Error convert. There we go. And let's just exit that. Let's save. And now we can actually use that function. So getInt argv1. Let's just save that and again run, and let's see if there was any errors. Okay, no error yet. Close. Thank you very much. That's all. Okay, so that is how we're going to use this. I'm going to quickly just rinse and repeat this instruction, and I will go modify this now to get all the various command line arguments, all 9 of them. Man, it's a lot. 6, 7, 8. All right. Why is it 9? Because remember, 0 is also included. Okay, save. Let's see if there's any questions and handle all the questions at this point in time. Can we use A2I in semester test 2? I must be honest, I historically did go and subtract marks specifically in that section of the command line argument for students that use that. I know Prof. Coulter has said, okay, you can use A2I. So I assume from this point onwards that we will allow A2I in the semester test 2 this year. A2I, as far as I can remember, is part of the C standard library, Mr. or Mrs. Cow. So SS stores strint, yes. So as soon as we do this, so the question that Mr. or Mrs. Tusi asked, as soon as, let's go back here, this instruction declares SS, and then it also initializes SS with that value inside SS. Right, so that is strint actually is stored inside SS. So, sir, do we use A2I if we don't want to use the getInt function? Yes, then you must use A2I. Okay, let's just quickly give the code for those watching this lecture at a later stage. There's the code for today. Did I see 723? There we go. Okay, the only other things that we should consider, this is part of the error checking and that kind of stuff. Now, we've already done quite good error checking because, remember, we used this getInt, and getInt actually helps us with a lot of error checking already. But there's a few other things that we can also do, and that is to make sure that these values, for instance, that we got is maybe not negative. I mean, we can't go build worlds that's negative rows and negative columns and or even zeros and stuff like that. So what we can perhaps do, this is something which I typically like to just put in, just because why not? And that is to create some kind of constant which is like, let's say, a maximum or a minimum value that our thing should be. And I'm just taking a number here, guys, and I'm saying 5. So my implementation for me, please note there's nothing in here that actually states it has to be minimum 5. Okay, I'm just doing it because it's good programming practice to have at least some range checking happening here. What I'm doing is I'm going to evaluate that these values should be at least 5 value itself. It shouldn't be less than that. So I'm going to just, after this, just make a comment here. Put command line arguments into variables. Then, after this, I will do basic range checking. That basically means I'm going to just create a very, very weird if statement that says if int rows is less than, I already forgot what I called, cancel. It's called min value. If int rows is less than min value, or if int columns is less than min value, or if int chinf is less than min value, or int chrec is less than min value, or int ch, what did I do now? That's not what I want to do. Chim is less than min value, or int total inf is less than min value. This is exhausting, my goodness. Or int total records is less than min value, or int total immune is less than min value. Then, my goodness, see error. Please ensure command line, get rid of this little thingy, arguments are at least 5. Something like that. Okay. And then exit error. I think it was range or RNG. Let me just quickly check. That's what I wanted. Okay, that is basic error, at least range checking. Let's save this. Let's build. Okay, all good. That is what I wanted to actually make sure that we get to. So this was the main objective of today. So the main objective was to show you that if we look at a problem, hey mouse, come alive. If we look at a problem like this, there will always be somewhere that describes exactly what must be supplied through the command line arguments and what should be added or by the user using the normal standard input stream. In this case, this was the most important thing that we have to ensure. And by looking at this requirement, we counted the actual number of command line arguments, and there were 1, 2, 3, 4, 5, 6, 7, 8 of them, plus the program name, which was 9. And that is what the first thing that we did. Then I showed you when we use the VPL, what we start with. You overload the main function using this specific 2 parameters. Remember, it has to be in this order: first integer and then character star star, or the array of strings. Then we counted our command line arguments, and if it wasn't the total number that was required, we outputted an error with a little bit of a help to inform the user that, hey, when you run it, just make it work properly. And then we exited our program with a specific error number. And then we went through a process of putting all those command line arguments into variables. And I showed you the preferred way of doing it is by using the string stream principle, meaning get int And getInt, the nice thing about it is our getInt function declared as a prototype. This is the implementation of getInt. It already includes error checking for us, where A2I doesn't do error checking. So there's a special section in your code that in your in the exams or semester test that you get marks for error checking, and this is an area to do error checking. Okay. Another area to potentially do error checking is obviously afterwards to do some basic range error checking. And that's why I specifically focus on this. I just want to quickly show you that error checking stuff, where that is included. Error handling, use of conventional error handling techniques. There you go. So all of this, what I did just now, contributes to that specific mark, field 3. Let's have a look at some of the questions that's maybe there. Min value helps with what, sir? Well, error, it's a range checking. Does it matter? So there was a question, sorry. So if I store the converted command line arguments in an array, will I lose marks? Probably not. I just find that it's sometimes more difficult to figure out which element in the array you need it to, well, then you can just as well keep it in the array. So you'll probably not lose marks, but it's not very good programming practice because you don't know which command line arguments and their meaning for it is. Let me see if I've missed anyone. If you make your own function, it can have some feedback if it fails. That is correct. Is this initialization 2? I believe it is. We can actually go test this. Yeah, so you basically give it a 0. In case we're short circuit coding, saves time. That is true. So if I store the convert command line, okay. Would it not be better to do all the range check in a function in the lib.cpp? That is possible, but it's just one line of code. Well, is it one line of code? Yeah, it's a little bit of a line of code. I find that this is a little bit less effort than actually creating a function, and then so you have to get a balance of what is effort and not. So in this case, I just felt it was too much effort to create an extra function for it. Does it matter if we use error range and error? Well, this error range wasn't declared at all, so we can't use error underscore range. You have to declare it whichever spelling you have. I used my spelling called that, so that is up to you. Depends on how you declare it. Okay, minimum value helps with error range checking. Is the minimum value a constant, or do we give it our own? I made mine a constant. Hopefully you saw that. What does minimum value do? It helps us with range checking to make sure your command lines don't give below a specific value. Yes, consistency matters. That's true. Sir, can you please show the use of the assert again? We'll get to that later. Int num, is this okay? I believe so. I think I've covered that. So if your program does not compile full semester, will it be capped at a certain percentage? Absolute. It will be capped at 40%. If this is also the same as the exam, does it mean next semester will be revision only, or will there be new content? Next semester will be total new content. Please, I mean, next semester is object-oriented program, lots of different things that you're going to read there. There is exams for both semesters, absolutely. Does the minimum value also have to be 5? No, as I've tried to explain, I just use it. There's nothing that indicates that it has to be 5. It is something that me as a person decided I wanted to implement. But I mean, it kind of makes sense that you have to have some kind of minimum. Otherwise, you can't have negative rows and columns. So at least 0 should be a minimum somewhere. Okay, guys, our time is up. Thank you very much for, I don't want to go over time. There are people that have to go into next stuff. So thank you very much for attending this lecture today.